In principle, a microwave oven heats no differently than any other type of heat transfer. At a molecular level, heat is a transfer of energy that results in increased motion of the molecules in a substance. Since we aren't quantum-sized, we observe this increase in motion as a rise in temperature. In a traditional oven or stove, we heat food by placing a pan on a burner or in the oven where the walls radiate heat, which cooks the outside of the food. The insides cook when heat transfers from the surface of the food to its interior. In contrast, energy from the magnetron penetrates into the food, which means the whole mass of the food can be cooked simultaneously. How does it do this? Well, our food is filled with water, which is positively charged at one end and negative at the other. To give these molecules more energy, we expose it to electromagnetic waves that emanate from the tube. By definition, the waves have the electrical and magnetic fields that change direction rapidly. For this oven, the direction of the fields change 2.45 billion times per second. Water will try to align with the radiation's electric field. The changing field rocks the water molecules back and forth rapidly, and molecular friction from this creates heat as the motion disrupts the hydrogen bonds between neighboring water molecules. Now, you can get an idea of the wavelength of the energy emitted from the magnetron using cheese. Now, you can see on here sections where the cheese is completely melted and other sections where it's completely unheated. The oven's metal walls only reflect waves of a length that fits inside the oven. This standing wave causes hot and cold spots inside the oven. The three-dimensional pattern of waves is difficult to predict, but the principle can be seen by looking at the waves in a single dimension. The peaks and valleys in the wave represent the greatest energy of the wave. Well, the nodes here correspond to the cold spots inside the chamber. If I measure the distance between melted cheese spots, I find about 2.5 inches. That would be half the wavelength, the distance between nodes, and is pretty close to the actual wavelength of microwave radiation used. Using that wavelength, I can estimate the microwave radiation's frequency. The frequency is related to the wavelength by the speed of light. I get an answer that only has a 4 or 5% error, not bad for this primitive measurement.